Okay, so for number 1, this is called the constant parent function, and we haven't talked about it much, but looking at all 4 of these on this helpful handout, it's that very first one that has a no slope flat line. So this is y equals 5, and it's saying to take this function and drop it down 6. So 5 plus a negative 6 or 5 minus 6 would leave you at negative 1. So this is right. G of x would be negative 1. 5 minus 6, negative 1. Good job. Number 2. This is a linear function, and we want to do a vertical shrink. It says here to do a vertical stretch or shrink, you multiply the entire equation by a, which is like distributing it. Now you can't distribute into bars. You can't even distribute into a quadratic. But here, you can distribute in 1/2 times 2 is 1x, and 1/2 times 8 is 4. So this represents the vertical shrink. We use distribution. Number 3. All right, here we have an absolute value equation, f of x, and we want to change it to g of x, and we want to show a reflection across the y-axis. So when I look at the bullet points, a reflection across the y-axis multiplies only x by negative 1. So all they did was put a negative 1 right here. You don't want to change the whole thing. The whole graph isn't changing. When you reflect across y, it's flipping this way, right? So you're working here on the positive x-axis, and you want to reflect it this way. The only thing that changes is the x's go from the positive side to the negative side. Okay, in a really simplistic way. So went from positive x's to negative x's. Thank you for bringing this up. Now, this is not distribution. I'm not multiplying it into this whole thing. You know, I'm not like, oh, it's let's look at what it's not. Like if I was to put a 2 outside the absolute value of x plus 3, I cannot make it 2x plus 6. That would be distributing it in, you know, putting it into all those parts. That is not what I'm doing. This is just putting a negative 1 next to x. It's like almost like an insert, not a distribution. Okay, and that's really well said. That's something that is very confusing about this. But when you're supposed to multiply to the whole thing, and I do say distribute, you end up putting it in front and behind the bars. You cannot distribute inside. So very good question there. The difference between distributing it through and just kind of inserting it. This is the one I've had to kind of do a lot of work on all day because we just haven't seen many problems like this. Let's see how we did. So this is the quadratic function. X plus 2 squared, the quadratic function family. We want a vertical stretch of 3. So good. Good job. On your paper, do you have a 3 right here? Yeah. That's a really good job. You guys got it. Okay, a vertical stretch of 3. So let's look. So I'm going to put a 3, and I'm going to write the function x plus 2 squared minus 4. And like it says right here, vertical stretch or shrink, multiply the entire equation by a. Distribute. So when I distribute into this entire equation, there is an invisible one here. It's not written. So when I multiply, first off, the 3 is going to land right in front of the parentheses. The original a, that's 1, becomes 3. I do not distribute into this quadratic, okay? PEMDAS says that exponents come before multiplication. So I can't break into this. It's just like the absolute value bars, that little gel. This exponent takes priority. I can't multiply in because of the exponent. So the 3 will go here. It will not go inside. Eventually it will. Once we apply that 2, we can distribute it in, but right there. And then I'm going to distribute it all the way to the end, that minus 4. So it looks like 3 parentheses x plus 2 squared minus 12. It landed in front, and it went all the way to the 4 at the end. Okay? You cannot go into the bars, you cannot go into the quadratic parentheses. Okay, vertical stretch of 3. It is followed by a horizontal translation left 5. So I have to think, how do I do horizontal translation? Horizontal translation, you place the value in parentheses with x, and you have to use the opposite sign. The h value here is responsible for horizontal translations, and again, you use opposite. So they went from 2 to 7. How did they do that? Okay, left 5. Typically left 5 we associate with negative 5 because that would be, left is negative on the number line. However, for horizontal translation, we use the opposite of what we would typically do. We're going to use plus 5. So right in these parentheses, right next to the x plus 2, I'm going to put in a plus 5. And that's how they landed at 3 parentheses x plus 7 squared minus 12. That was a very good job.